All right, so the purpose of this lab is to have an object that is accelerating and have that on a velocity versus time graph. And as we said, our velocity versus time graph is going to look like this. Okay? Now, if everything was done absolutely perfect, the y-intercept of this line would be what? It would be 0. Okay, because if everything was done perfectly, the initial velocity of the cart should be 0 because we're just going to hold it and then we're going to let it go. Okay, and then it'll go down the ramp. Our initial velocity of data might actually be 0, but when we look at the data and it gets plotted, it's probably going to be some very, very small number that's not quite 0. Right? What we have to understand is every one of these lines, okay, is going to have an equation, okay, and that each part of this equation is going to represent something important from the graph. Okay? What's on the x-axis? Time. What's on the y-axis? Velocity. Okay, so that means that y and b are both velocities. Okay? It means x is time. M is the slope. When I calculate the slope of this line and I go y minus b over x, what does the slope represent?
Acceleration.
It represents the acceleration of the cart. Okay? That's going to be important for a lot of things, including your hypothesis, okay? And some of the analysis. Okay? So keep that in mind. All right. So for our design, variables. We're building a graph like that. Okay? The x-axis is always our manipulated variable. Right? Once again, we're kind of determining the time, okay, that this experiment goes over. Okay? Some of the times might be slightly different, but we're going to do our best to make sure it's the same amount of time for all the carts. Okay? The speed is obviously, or the velocity is obviously going to change. Okay? If something is changing as a result of what we do, then it's usually considered to be responding. And then you need 3 controlled variables. Now, that part I'm not going to give you because I just gave you the first 2. But here's what you need to envision for this lab. You're going to be using these carts, okay, and these ramps. Now there's one plastic one and the rest are all made out of wood. Okay. So, what pulls the cart down the ramp? Gravity. Is that going to change at all during the lab? Would it really mess up this lab if it did? Okay. How are you controlling that?
The slope of the wood.
Well, actually, I'm going to change the slope of the wood, but that's not the manipulated variable. Don't put that in. Okay? We're just doing different trials, so we got lots of comparisons. Okay? But gravity is going to stay the same throughout the entire experiment. The way I make sure gravity stays the same is I do what?
Drop it and pushing it.
No, but that's another control variable. That was not a bad idea. Okay. I think you guys are really overthinking it. If I stay here, does gravity stay the same? Doesn't change, right? Unless I go to Mars or the moon. Okay? Gravity's going to stay the same throughout the experiment. Agreed? If it changes, we're in big trouble because the Earth either got a lot more massive or a lot lighter, or we moved a long way away from it. Okay? Those are the only things that can make gravity different. And we are hopefully not doing any one of those while the cart goes down the ramp. Okay? I want you to think about some other things that are going to stay the same throughout the runs. Okay? All of the runs, for that matter. Okay? Think about your cart, think about your ramp, okay? Think about things that might be present there, okay? That we can observe, okay? That are going to stay the same, that could affect the acceleration of the cart, because one of the things that we want to stay constant throughout this is the acceleration of the cart. Okay? If it doesn't, then we don't get a nice straight line. All right, so that should help you with the design. For our hypothesis, okay? So the if part of the hypothesis, I want a definition of acceleration. Okay? We've talked about acceleration a bunch of times. We actually haven't done anything with acceleration other than calculate it from a graph. But if an object is accelerating, something is happening. You basically just need to tell me what. If acceleration is this, or if acceleration is when an object does this, okay, then you're good. That's what I'm looking for the if part. Okay, so if acceleration is, okay, basically define acceleration. Okay, the and part, as always, describes the experiment. Okay, carts are going to be allowed to accelerate down a ramp with their velocities and times recorded. Okay, in the then part, what will the velocity versus time graph look like? So tell me, what's it going to look like? Oh, spoiler alert, there it is. Okay, and how can a velocity versus time graph calculate acceleration? Oh, spoiler alert, there it is. See how I said that would be really helpful for your hypothesis? Okay, on to the procedure. Couple of things with these carts. Don't let that startle you. It's going to happen to you at some point while you're using these carts. Okay? There's a little plunger, spring-loaded plunger on the back of each one of these carts that is triggered by this little button right here. Okay? If you accidentally, set the cart down or you're messing around with it and you press that button, see? That's what'll happen. Okay? I actually almost dropped one of these a couple of weeks ago in my physics class because I accidentally bumped it and it startled me. Okay? So be mindful of that. The best thing to do is to just leave it in that position because then pressing the button does nothing. Okay, so just leave it out. There's a forward and a backward on these carts. Okay, there's a little insignia right here on the inside that shows you that X is that way. So the end of the cart that has this bumper on it is the front. Make sure your cart goes down the ramp that way. Otherwise, your graph is going to go down because the cart will think it's accelerating backwards because it is. Okay, so make sure it's bumper end pointed down. All right, and that bumper should be tight. This one wasn't. Okay, just so it doesn't move too much. Okay, everybody with me there? Okay, so the experiment's going to go like this. Hopefully you installed the SparkView app on your phone the other day. Okay, so you're going to open the SparkView app. You know what? Let's get into our groups. Leave this apparatus here for me. Let's get into our groups and then we can walk through it together. Each person that's going to be the data recorder, they can come up and we can do this part. Okay, so when you open up that file, your data file, you're going to get this mess, okay? And you're going to get the open with option. Okay, so click open with, and Google Sheets should be one of your options. Okay, so you're just going to click on Google Sheets, and Google Sheets will convert it. It's going to take a few seconds, but there it is. Now you're probably looking at that and going, Coderre, that only looks a little bit different than the mess I was looking at before. You're right. But we don't need all of the data that's on here. If you remember, on the first lab, I did all the data management for you. Okay? And it took me about 5 or 10 minutes to trim the data file for you. Now you're going to trim it. Okay? I'm going to show you what I did. There are a whole bunch of columns that we don't need. Okay? The only columns we need are the time for run 1 and all of the velocities. Everything else we're going to delete. Okay? So what you want to do is highlight a whole column by pressing the top of that column, okay? And then you go to edit and you go to delete, okay? And oh, it didn't give me what I wanted. Hang on. Column A. Okay, so you're going to delete that whole column. Okay, now I've got time, run 1 as my first column. Okay, now I want to delete a whole bunch of other things. Now you guys can do this a little easier than I can because you have the keyboard. Okay, I'm going to try and use my keyboard here to do this as well. Okay, here are all the columns we don't want. Okay, force for run 1. And then I'm going to click on that and then I'm just going to hold Control down and I'm going to press all the other columns I want to get rid of. Come on. All right. I don't want to delete velocity for run 1. I want to keep that one. Okay? And then I'm going to go to acceleration, angular velocity, for run 2, get rid of that, don't want it either. Okay, force for run 2, don't want that. All right, before I run out of screen, I'm going to go to edit. I'm going to say delete. Okay, selected columns. All right, so now they're all deleted. Okay, I've got time for run 1, velocity for run 1, and I still have a whole bunch of columns I need to delete. Okay, so delete everything except time for run 1 and the velocity runs that you want to keep. If your group had one run that you're not keeping, you have to delete that one as well. Okay, if a couple of groups had one run that didn't go quite right. Okay, if that's the case, make sure you delete that run as well. All right, so I'm just going to hold control down and I am going to get rid of all the columns I don't want. I'm keeping that one. So we're deleting a lot out of here. Whoops. Oh, there we go. Okay, good. Okay, so I'm down to the things I want now. Okay, I'm down to the time for run 1 and the velocities for runs 1 through 5. Okay, so that's the first bit of trimming. Yeah, you don't have to do what I'm doing here, but because I have such a wide screen, it helps if I have extra blank columns when I do this. All right, so the next thing I want to do is build a graph, okay, which we already know how to do. We're just building a graph in Google Sheets now. Okay, so I'm just going to highlight all my data, which now doesn't seem quite so insurmountable because I deleted all the other crap that I didn't need. Okay, so once I've got it all highlighted, insert chart. Okay, and if you're falling behind, guys, don't worry, I'm recording all of this, you can always come back. All right, it picked the wrong kind of chart, you don't want that. Okay, so I'm going to go to a scatter plot. Okay, and it put time there. It's got velocity on the y-axis, which is exactly the way I want it. I'd want to do some stuff with the title and put a label here, but okay, to save time, I'm not going to do that for right now. And I'm going to start modifying some of this data because I've got some data that I don't want to keep. Okay, so now I need to trim a bit of the data. Okay, So whoever did this data did a good job of starting it before and not having anything like that was flat on zero, okay? But I've got a few here that I've got to trim the ends of. So if I'm looking at these runs here, okay, I'm going to want to trim some of that data off. So for the green run, so that's run 4, it stops accelerating right at 0.5 seconds. The next one is lower. So I'm going to delete all the data for run 4 after 0.5 seconds. So here's run 4, there's 0.5 seconds. So, okay, I'm going to highlight all that, and this is kind of important. If you're deleting anything before, so if you've got some flat spots before, so I'll just show you what I mean here. Okay, if I have to delete some numbers at the beginning, okay, this is what you do. So click in the top one, highlight the ones you need that are like, they're probably all the same. They're probably all the same number. Okay, highlight them, click edit, and go to delete. And make sure you say cells and shift up. That will make sure you don't get a bunch of blank cells. Okay, it'll shift it up so it starts at 0. Okay, so if I do that, it'll shift everything up. I don't want to delete those ones because this data doesn't really work that way. Okay. But what I want to do for run 4 is I want to delete everything after 0.5 seconds. So there's 0.55 seconds. I want to delete everything there. Okay, delete, shift cells up. All right, and you can see it cut those off, which is good. They weren't part of the acceleration. So I want to delete any points that are not part of the diagonal line. Okay, and I just look on the graph to see where they are. So if I'm looking at run 5, that's these orange lines here. Okay, then I'm looking at, okay, after probably after 1 second, I'll probably cut it off because it starts to flatten. Okay, these points here, and then they start to drop off. So I'm going to delete all the points for run 5 after 1 second. Okay. Oh, not shift left, shift up. Okay, and now you can see those ones are cut off as well. All right. Did you guys change the angle of yours as well?
Sorry?
Did you guys change the incline as you went?
Yeah.
All right, and then for run 3, okay, same thing, but I'm probably looking at deleting everything after maybe 1 point. Well, if I'm looking at this here, it only accelerated to there, then it started to slow down at 1.1 seconds. So everything after 1.1 I'll take off. Okay, so now that one's cut off. Okay, got to do the same thing with the blue line. Probably at 1 second is where I want to take that off. The blue line is run 1. Okay, so after 1 second. So there is a bit of trimming that has to happen. There always is. Okay, and then run 2, I don't think I have to take anything off of. The rest looks good. So now I've got my incline lines. Okay, now I'll put my trend lines on, okay, which we already know how to do. Okay, but if you've forgotten, you go to Customize, Series, okay, and you click on Trend Line, and then you tell it to use an equation. Okay, now I've got my equation for each line. Okay, if you're having some trouble, let me know, and I will come around and help. Okay. And it's okay, guys, if you're not at the analysis yet, but I just want to make sure that it's in the recording here. Okay, so for the analysis, you have the chart, okay, that you're supposed to fill in. Okay, that looks like this. All right, so for the slope, put in the slopes from your graph. Okay, so if I'm looking at my graph, okay, I'd say, all right, velocity for run 1 is 0.202, and put in the appropriate units. Okay, that slope represents something that we talked about earlier, and that something has specific units. Put them in there. Okay, and then for B, Okay, so next one here is put in the value for b from your equation. Okay, because it's y equals mx plus b, put it in there. Put the units in for it. Okay, b has specific units as well. Right? And then displacement over the whole trip. This is something you're going to want to pay attention to. Okay, so displacement over the whole trip. So if I get a graph, okay, let's say it looked something like that, okay, because most of our graphs are going to look something like that. Okay, I've got to calculate the displacement. How do I get displacement from a velocity time graph? I find the area under the line, okay, between the line and the x-axis. Okay, so these don't all start at 0, okay, but we can kind of say that they do, just for simplicity's sake. Okay, but if they don't, then I've got to look at, you know, that there's maybe a rectangle and a triangle, or just a triangle. All of these, okay, have negative y-intercepts. That means that they are just going to be triangles. So I just need the base of the triangle, okay, and the height of the triangle. The base is whatever time that data ends at, okay, and then the height you can calculate, okay, using your equation. Calculate what is y at the last time you had, okay, and then you'll be able to calculate the areas in there. Okay, so it's just the calculations we were doing before, some y equals mx plus b, and some area calculations. So if I'm looking at my yellow line here, okay, listening guys, if I'm looking at my yellow line, okay, if I want to calculate the area for run 3, okay, I would look at my data and figure out what my last x value is for run 3. So for me, for run 3, 1, 2, 3, okay, it's 1.3 seconds. All right, so the next thing I would do then is say, okay, what was y at 1.3 seconds? So I take this here equation, and I would say, all right, y equals 1.13 times 1.3 plus negative 0.0403, okay, and that would be my height. Okay, and then from there I can calculate the area under the line. Okay, just base times height over 2 after that. Okay, so you'll probably want to come back to this later because I just gave you how to fill in that chart. Okay, that's all you're doing for the analysis is filling in that chart, but make sure you show your work. Okay, I'm going to be looking for your work. If you do it on paper, take a picture of it, okay, and show it to me after, okay, or just insert it into the document. Okay, all right, and then don't forget these. Okay, question number 2 from your data: which trial had the greatest acceleration? Make sure you write that in there. It's just a trial, whatever. Okay.